So now we're going to do some graphing of radical functions. Now this is not graphing on the number line, this is graphing in a real plane, also known as the Euclidean plane or the Cartesian plane, right? Has all these names. Exercise 1, graph f of x equals square root of x plus 1. Well, the first thing to do is to find the domain, because that tells you what values you can use for x. And this is a square root, so it has an even index. So this one is going to have an endpoint. And so I want to know where the endpoint is. The endpoint is always where the radicand is 0. So the endpoint I can find by setting x plus 1 equal to 0. Right? So this is the domain x plus 1 greater than or equal to 0. And I just wrote out here what I just told you. Find the domain of f first so we know what values we can use for x. Especially important is the endpoint of the domain. So x plus 1 greater than or equal to 0 means x is greater than or equal to negative 1. So the endpoint of the domain is negative 1. Okay, so I definitely want to put in negative 1 into f. So I'll make a little table. First column being x, the second column is f of x, which is the output. And I just wrote the formula there just so I don't have to look all over my page. Right? F of x equals square root of x plus 1. And I'm going to put in negative 1. That's the endpoint of the domain. Now this negative 1, 0 isn't interval on the real number line. That's a point in the plane. The y-coordinate is 0. And the x-coordinate's negative 1. Okay, so I just plugged negative 1 into square root of x plus 1. I got square root of 0, which is 0. And now, for square roots, that's an endpoint. And so it's either going to go, I either need numbers smaller than negative 1 or larger. But you can see, since I've got x is greater than or equal to negative 1, I'll just put in numbers larger than negative 1. So an easy one would be 0. Put in 0 for x. That gives me square root of 1 is 1. So I'd have 0, 1. You should do at least 3 for these. For even indices, you should do at least 3. For odd, you should do at least 5 points. You'll see why when we do the odd one. So the smart way to do this is to choose values of x that give you integers for f of x. And since we're doing square roots, that means we want x plus 1 to be a perfect square. So square root of 1, square root of 4, square root of 0, square root of 1, square root of 4, square root of 9 if I wanted another one. But I would just use 0, 1, and 4. So I want x plus 1 to be 1, x plus 1 to be 4, and I already have x plus 1 equal to 0. But I did a fourth one, which you don't have to do. X plus 1 is 9. That's a little overkill. And then just solve each of these. So x plus 1 equals 1. You just subtract the 1's, right? And you get x equals 0. X plus 1 equals 4. You put that 1 on the right side. It becomes 4 minus 1. So x is 3. Oops, I decided to fill that in. So first I had x plus 1 equals 1. Okay, so that means I want to use x equals 0. So if x is 0 and you plug that in here, of course, you get 0 plus 1 is 1, square root of 1 is 1, right? And then I'm taking my argument, my radicand, equal to a perfect 4, a perfect square 4, right? And then if you put this term here of 1 on the right, it becomes minus 1. So you get x equals 3. And then you put that 3 here, plug the 3 into the equation, you get square root of 4, which is 2. See, so it comes out with integers. So look what's happening with the outputs. 0, 1, 2. You're getting consecutive integers, actually. So I take my radicand, set it equal to the next perfect square, 9. Right? And then I solve that, and I get x equals 8. So I use x equals 8 for my input. And when you put that in here, you get square root of 9, which is 3. And then I'm going to graph this, and of course, you'll have a grid that you can graph on that's already prepared for you. But when I'm drawing this up freehand, I just make sure I include all these 4 points that I have in my, these 4 points. Okay. So this is the point -1, 0. So that's here. Okay. And then 0, 1 is right up here. This is the endpoint here. 3, 2 is here. 1, 2, 3, 1, 2, right? 8, 3, you go over 8 and up 3 is right here. Now, if you're graphing this by hand, you make it so it looks vertical here, not so it's pointy. So it looks vertical, but it immediately starts curving. It's actually the shape of a sideways parabola, except that you left off the bottom half. To include the bottom half, you'd have to have plus or minus square root, which some of you have probably seen before, plus or minus square root. It's a sideways parabola here. Okay, so that's the basic shape. It's not like pointy, like it doesn't head directly from here to here. It has to go up first a little bit. Right? Anyway, that's what that looks like. And again, I only really needed to do 1, 2, 3. So you want the endpoint and 2 other points to one side. Now with the cube root, you'll see it looks like this, and so you'll need the vertex, which is the endpoint here. For this one, but if it's a cube root, it won't be an endpoint, but it'll still be a vertex, and you'll go 2 to one side and then 2 points to the other side, so it'll be a total of 5 points. So I'll show you an example.